Welcome, everybody. Good evening. My name is Kirk Froggatt. I'm on the faculty here at the Technological Leadership Institute, and very, very delighted to have such a good turnout this evening. So our mission here at the Technological Leadership Institute is to develop local and global leaders for technology-intensive enterprises. We offer programs that help technical professionals navigate the uncertainty and complexity inherent in translating technical ideas into customer solutions that generate economic value. We are interdisciplinary by design because the process of technology commercialization is inherently multidisciplinary and requires cross-discipline collaboration. Our core programs include 3 Master of Science programs in Management of Technology, Medical Device Innovation, and Security Technologies. Our ST program really helps our students understand how to manage risk and deploy technology to secure vital infrastructure and enterprise assets ranging from digital information and cyber networks to physical infrastructure like buildings, bridges, power grids, and power plants, and important assets like food and water supplies. Our MDI program helps students understand how to navigate and manage innovation within the very complex healthcare ecosystem, where non-technical variables like regulatory approvals, clinical trials, insurance, and evolving healthcare mandates and metrics often make or break commercial success. In our MOT program, students learn how to lead and manage profitable technology businesses at both the product and the portfolio levels. They also learn how to manage the dual transformation challenge that is inherent in every enterprise today. How do we currently deliver short-term results by incrementally improving current products and technologies in existing markets, i.e. stay alive, and build the next generation growth engine by exploring and exploiting new technologies that will build the future, i.e. not get killed in the long term. These are very different but equally important innovation games for technology leaders. And then beyond our MS programs, we have 3 graduate minors that are available to any graduate students across the university, and we offer customized short courses for corporations or communities that have special interests that fit with our capabilities. So if you'd like to learn anything more about TLI's programs, I encourage you, if it's about the master's program, talk to an alum or current student. They'll have the best information for you, but we also have a number of staff members here that would be happy to talk with you as well. So, speaking of innovation games, I'd like to provide just a bit of context before we begin in earnest tonight's discussion. For more than a decade, Booz Allen and PricewaterhouseCoopers have been conducting research on the top 1,000 R&D spenders around the globe. Their objective is to identify best practices and key success factors that distinguish the best performing R&D companies from the rest. They define best performing as companies that have sustained financial performance in the top quartile of their industry. So what big factors distinguish these top financial performers from the rest of the high R&D spenders? One of the most interesting findings that they've replicated over and over is that more R&D spending is not correlated with better sustained financial performance. I know that's counterintuitive to a lot of folks, but simply spending more does not have any direct relationship with better sustained financial performance. And we define more as both absolute dollars and revenue as a percent of, or R&D spend as a percent of revenue. Rather than the amount spent on R&D, it's the capability these companies develop to translate their R&D spending into commercial value that distinguishes them as top performers. These top quartile performers are much more likely to focus deliberately on one of the 3 innovation strategies you see here, and they choose the one that best aligns with their business strategy. Then they develop superior capability by deploying the right talent, mastering the right processes, and developing the right culture to win in their chosen strategy. Ultimately, it is not how much they spend, but how well they focus and manage their talent, processes, and culture that distinguishes these best performers. Traditional stage gate processes, combined with more recent best practices like agile development, lean startup, and design thinking, are now commonly employed and typically work quite well for those companies that are pursuing the need seeker and market reader strategies. The technology driver strategy, however, is uniquely challenging. The fuzzy front end of breakthrough technology development is fraught with technical application and/or regulatory uncertainty, in addition to market and business model uncertainty. Our current practices are not always well suited to the front end of technology-driven innovation, especially for breakthrough and platform technologies. So, beyond the traditional technology push and market pull approaches, are there any methods and tools we can employ to lower the risk of early-stage technology innovation? This is really the question for tonight. So let me introduce Dr. Andrew Maxwell. I had a call maybe about 6 months ago now from a colleague that happened to know both of us, and this colleague is my connection through the Midwest Engineering Entrepreneurship Network. And after we talked, he said, "Oh my God, you've got to meet Andrew Maxwell. You two are talking about the same problem, you're looking at it from the same perspective, and I think he's got some really interesting approaches that you'd want to learn about." So, got on the phone, talked to Andrew, and fortunately he agreed to come and visit us and is here tonight, and will spend some time with us tomorrow as well. Dr. Maxwell is Associate Professor of Engineering at York University in Toronto. He also serves as Director of the Bergeron Engineers in Science and Technology program there. He has a very interesting academic background and sort of a perfect background from our perspective at TLI, because he's got a bachelor's in electrical engineering, an MBA, and a PhD in management of technology. Both the technical depth and the management of technology breadth that is needed to be really effective at commercializing technology. The other thing that I really appreciate about his background is that he has both academic expertise in the field and real-world experience. He's been the co-founder of 4 ventures, and I think it's about a decade that you've served as Chief Innovation Officer at the Canadian Innovation Center. So, great opportunity to live and learn here, and so let's let the games begin, and welcome Dr. Andrew Maxwell.
Thank you very much, Kurt. So, good evening. Thank you for inviting me. Maybe I should start by kind of giving my background, because I had an engineering degree and an MBA, worked in big technology companies for 20 years, realized I actually liked starting things and not finishing them, actually, which was a problem when I came to my PhD. But so I started 4 technology companies in a row, and the minute it got to the point where you had to call the sales guy to make sure that they made the sales call, or you had to fill out expense reports, I left and started another one, because my love was finding technologies to do important things and turning them from an idea into a business. And what I left for was actually to join the University of Toronto's Technology Transfer Office. And so my background in this was actually from U of T is Canada's largest research university. It came from the experiences in there of working with licensing technology. We set up the first university incubator in Canada. We started 30 companies, teaching tech commercialization at the business school. And in doing that, I came to one conclusion that, well, actually more than one. One, we had no clue how to teach entrepreneurship. Number 2, we didn't know what technology commercialization was, and certainly the universities were not a place to do it. And number 3, there was a lot of really great research out there that would give us indications, but we're a university, why would we rely on research to decide what we do when you can actually use like political expediency? So I decided I wanted to change how universities worked in this area, and this led to my research and led to me doing a PhD. And for those that are in this space, probably you would recognize that if you're in Canada and want to do a PhD in technology commercialization or tech entrepreneurship, you would do it at University of Waterloo, which has been started more companies out of there than the whole of the rest of the Canadian ecosystem together. And it has a big advantage: no business school. So everything there is driven by the engineering, everything there is driven by community. It was started in 1957 and with a mandate to serve local industry and to build local capabilities. And when you build that into your DNA, it actually gives a flavor that explains why it's been so successful. So that's what I started out trying to do. And I also recognized, we had not planned this, but it's kind of the resonance between Kirk and I from that paper. What we recognized was that part of the reason we were doing a bad job in technology commercialization is because we weren't applying consistent processes and theories and insights, or looking at behaviors. And of course, innovation management, I'm in an engineering school now, and sometimes the people in the school don't understand what I do because all I do is look at behaviors. I say rather than the behaviors of particles, I look at the behaviors of people. The other thing that I learned from doing this is that listen to your wife, because my wife has an MBA and a psychology degree, works in leadership development and coaching, change management. So like after 20 years of doing the technical stuff, I suddenly realized that it's actually about the people, which I should have known, but I guess I'm an engineer, so it takes a while. Sometimes we're a bit slow. So I'm going to talk about why this is important. And to some extent, I'm preaching to the converted, but I think it's really important to understand the motivation. And then I'm going to talk about what we're doing wrong. And then I'm going to explain the process that we're starting to use and trying to share with others with a goal of actually changing, moving the needle on innovation. So first of all, why is technology commercialization important? And I'm really talking about it in a university setting. It applies in an industry setting too, but in a university setting. So I think the first reason is that it's important because it actually justifies why universities exist. We get all this research funding, we do a bunch of different things, we educate people. And if at the end of the day, all we do is publish papers and don't actually see the results of our technology developments translate into new knowledge, then I think that we're kind of missing the point. And increasingly, we're all under financial pressures in our institutions. And I'm not suggesting, by the way, at any stretch, that the impact on the university is directly related to licensing fees. I think that's an actual, I'm going to say something maybe heresy here, but I think that's the opposite way to think about it. I think it's about creating value from your technology, which eventually will have some positive impact. And I have a paper on this. The mandate at Waterloo was create really successful technology businesses, and we know where you live. And so it was much more a benevolent ecosystem. I think that the second reason that's important is universities play a central role in regional economies. And sometimes I think we forget that. Sometimes the ivory tower universities forget that. They don't remember why they exist or what they're doing. And if we create new technologies, then we create these scalable enterprises that create local wealth. They create local jobs, they create co-op opportunities. A lot of our grad students working in a lab, if that technology is commercialized, they can go and work in that company. So working for the big company is not the only option. Creating that local wealth is really important. And that has a little hook in it because it means licensing is probably not really relevant. I'm not saying as a mechanism for moving money backwards and forwards. I'm saying if you license, 85% of licenses go outside your city or outside your region or outside your state, which really doesn't help you very much, especially if you're asking the state for money. But most startups start up inside your state, in fact, in your parking lot or in your science park or wherever, and that has a big multiplier effect. So that's the second reason it's important. And the third reason that is really important, and the one that kind of makes me get up every day and drives what I'm trying to do, is that the world is faced with many, many very large challenges, whether it's cybersecurity or clean water or food. All of these things are big challenges. And the way we will solve them is by technology. And so there's a moral imperative to have our students and our research focused on solving those big problems and taking our solutions and implementing them. And that's an equally important part and the moral imperative behind technology commercialization. So I think that we can operate at the university level, the community level, but at the societal level. And those are the three areas that we try to work on. So I think that's really the driving force behind it. It's the passion that I have behind it. But it kind of sets the stage. So what's the problem? Well, we suck at technology commercialization. Recent reports show that less than 1% of the technologies developed in a university actually get out into the marketplace. Most universities spend more running their tech transfer offices than they even make from licensing revenue. And did it ever occur to you, and of course I know no one in tech transfer here, so I'm not pointing any fingers, that actually the word technology transfer is an oxymoron, because the last thing they actually want to do is transfer the technology. They actually want to stop the technology transfer. That was certainly my experience at the University of Toronto. We did more things to get in the way of technology getting out and being used than we ever did to make it happen. And there's a lot of reasons for that. So our success rates are low. And we've got to do something about it for the reasons that I said, the immoral imperative, the creating jobs for our students, the creating wealth for our society. The problem is that the way we work in this space has a number of structural challenges. A lot of them are to do with assumptions about who does what in a university, about what the role of technology commercialization is. In fact, many institutions design policies that actually inhibit technology commercialization. So the first reason that there's a problem is that the goals and objectives of the faculty and the researchers inside a university are not aligned with the activities of the Technology Transfer Office. And so those disconnects cause disconnects in process, disconnects in outcome, disconnects in value, and create really big issues. The second one is that Technology Transfer Office are not really resourced, both in terms of money and people, to do anything really meaningful. And by that, I'm kind of going back to my previous comment, that licensing might be interesting, but it's not really going to solve the problems that I want to solve, the reasons that I think technology commercialization is important. And the tech transfer office don't have the wherewithal to do the funding startups that are going to take 5 years before they make any money, and it require lots of expertise and networking and lots of risk-taking, which is kind of culturally different from what universities do. So it's very hard to do that inside the tech transfer office. Universities always also mainly think that there's only one way to commercialize the technology, and that's licensing. And I think we know there's a lot more ways, and of course, I'm trying to emphasize the fact that technology entrepreneurship is really a key driver, and preparing technology for entrepreneurship is different from preparing them for licensing. Two more problems. One is that we actually don't incent our researchers for commercial success in most institutions. We have this strange thing that's called tenure. And if you're working for tenure, in most universities, and again, I don't know the detailed policies here, so I apologize, but in most universities, tenure means don't do commercialization, get papers published. And if you're actually in certain institutions, it certainly happened to me at University of Toronto, if you started doing things that were not to do with publishing a paper, like going to work with a company or doing some consulting on solving a technology problem, you were told by your boss, don't do this because it's going to put your tenure at risk. And after 5 years or however long it takes you to get tenure of being trained, don't do anything useful with your technology, just publish it. That kind of sets a pattern for the future. So there really is no incentives, and how universities view the gains from commercializing technology becomes very interesting. And unfortunately, what we do is we hear the stories of the top 10% of universities who actually make some money from this, and that kind of informs the opinion of everyone else. And reality is, there are only a few universities in those top 10%. They haven't changed much in 25 years. If you're in those 10%, well, maybe you could do something useful. If you're not, don't play by their rules. You have to change the game. And I think that's part of the lesson. And the final thing is that the technology commercialization process only starts once the technology is finished. And this is the traditional technology push model. And it's this one that I'm actually going to talk about the most. Because the idea that you finish a technology and then you try and find a customer or sell it is just fundamentally flawed. And we've seen a lot of new things coming out, StageGate and Lean Startup. Well, StageGate's not new. Bob invented it, I guess, 30 years ago. By the way, you told the history of the Canadian Innovation Centre. Bob was the Chief Innovation Officer at the Canadian Innovation Centre like 30 years ago. So there's a history there. The reality is that starting the process when the technology is finished is unlikely to lead to commercial success. Now, there are a bunch of other factors that we could talk about that make that low, that then inhibit the rate of success, and some of those I've given some details on, like IP policy and culture and all of those other things, changing tenure policies. But I'm not going to talk about those because we could go off at a tangent. We could be here for a week. But I'm going to talk about process because what we did was we set out to develop a process that would help address this. A process that's meant to run in parallel with the development of technology, not subsequent to it or instead of it. And this is really interesting because we actually believe one thing, we believe that if you want to create the next generation of technologies that are going to drive wealth creation, you need to bring together that technology push, which creates companies that have something that they can use to protect them from competitors with a profound understanding of the market. Now, Alex Osterwald, I'm not going to say he's a good friend, but he's a friend of mine. His company Strategizer, also in Toronto, by the way, is constantly working on issues, and people that know about his stuff will know about the business model canvas. But what you may not have seen in the business model canvas is the idea of centers of innovation, epicenters of innovation, he calls it. And so what he says is, where does the idea start, and how does that influence the business model of the company? Okay? And you can see, if you know the canvas very well, you'll know that this one starts at the bottom, and you do revenue and costs, and that's where your whole business is focused. And most of our businesses are focused on that. They start with the revenue cost and do everything based on that. The ones that are over here start with design thinking. What are you going to offer a customer? How do you make the customer delight the customer? That's the typical model that kind of comes out from the venture capital background. It's really understanding a need. There is nothing wrong with it, except that if you understand a need, how do you know that you're the best one to solve it? So the answer is, maybe understanding it is good and it gives you an advantage, but unfortunately I've seen so many people who identified a need before other people, started to solve it, and then someone else came along bigger and faster and better and kind of took that. That's the second is the new first. So it's a very important technique and it's very appropriate. But the one that we start with is the technology-centric one. The understanding that what we do is we start with the technology because that gives us an inherent advantage, and we see what can we do with that technology. Now, I want to say something before I go into the details of this process that we use, because it's really important to understand the approach. There's lots of ways of describing it. It's definitely a stage gate approach. It's definitely a real options approach. The idea is that you start off the project by having a bunch of technologies that you're working on, or a bunch of different manifestations of those technologies. And you push them forward until either you pivot, or you kill them, or decide to continue. So we use this process in one of my graduate classes. It's a class called Technology Commercialization. And at the start of the class, there's typically 30 people in the room. About 26 of them are engineers that bring their own technology into the room, or borrow something from a tech transfer office. And the other 4 tend to be like business school students or innovation management. And they all start off with their own technology, and they take it through this 8-step process, which I'm going to briefly introduce. And every week, the first thing they do is they use the framework that we give them, and I'm going to give it you very quickly, to explain their business, to explain where they're at and what they're doing. They get feedback from the class. They go home, they read the feedback. It's posted in real time online. And they have a choice. They can keep going. They can say, yeah, we hit it, we nailed this, it's going forward great. We have to pivot. We're going to do something slightly different. Or there's no way in a month of Sundays we're going to be successful, we have to kill the project. Now, because they're in a class together, and they have to finish the class, when they kill one project, they join another team. So typically, next week is the last week of the class. We started with 32 projects. We have 35 students, 32 projects. We're down to 7. We build the killing of projects into the process. Bob Cooper calls it deciding which puppy to kill. It's kind of an interesting idea because our research is always our baby, and it's something that we care about and we think is really nice. But we decide it ourselves. So we teach our students how to decide themselves using objective tools and frameworks which ones to kill. And then they decide. We never tell them they have to kill it, but they say, I've just decided that this is not going forward. Sometimes if I think it's really promising, but they should pivot, I might say, well, before you do that, come and chat and give me a interim presentation. The feedback they use is not really that much my feedback, it's the class's feedback, because the class learns by critiquing. They actually don't learn by working on their own project, they work by critiquing the others. And we run this not just as graduate classes, we run it undergraduate capstone courses for engineering, and we also run it in 2-day workshops where we involve the business school and the community as a way of kind of understanding the process. So let me tell you the 8 things that we do which I'm going to say are changing mindsets through our 8 steps. That word wasn't on the slides that I sent you this morning. I spent 2 hours with Keen Network on the phone with John, and he said, you have to put mindsets in here. So I realized, actually it is. What we're doing is you're using process and formula and approaches to change people's mindsets. So what are the mindsets we do? So first of all, people come into class with a technology. And they know that technology better than anyone else, and usually it has something better than other people's. Well, that's what they're working on. And we don't ask them too much about the technology or to explain how it works. Although, by the way, the first presentation is always 10 minutes of how it works. And we go, yes, but. The nice thing is we have engineers from every discipline: biomedical, civil, mechanical, electrical, computer. So if I don't tell them to shut up, the other people do. Say, okay, just make it, dumb it down for us. So they're all graduate engineers. The first thing we ask them to do is to say, park the idea of where you think you want to apply that technology. Park it at the side. Don't forget it, because that should be on your list. And make a list of all the possible applications for that technology. And it's really important that you kind of do. It's a combination of creative problem solving and stage gate, that you diverge around a number of different applications. And I can give you lots of examples. I mentioned to Kirk, I've brought one of the projects from class with me. I can also share their pitch deck, because now it's a business, they're raising money. But the reason for the contrast is the process for arriving at what they should do is nothing to do with what it looks like now as a pitch. So maybe you can apply it somewhere else. And I've done lots of examples of this. The classic one that I did was actually with Osram, when they were trying to get into LED lighting, and they didn't know where LED lighting was going to best be used. Where was the best market for LED? And they had no mechanism for doing it. And we used this process with them to help them do that. And then what they then wanted to do was a market study, 6-month market study on the top applications for LED lighting. The CEO of Osram is an accountant. And I said, why don't you try and find a distribution partner in each of the fields and see if they can sell some, and see based on sales rather than a market study. And so they picked 8 fields. They found 8 distributors. The head of R&D for Osram said, well, I can't say that to my boss. It's a German company. He says you have to do it this way, you have to do it this way. But you can say it. So I went to pitch to him the idea of doing the study by actually experimenting, which is actually a fundamental part of this. It's all around experimenting, gathering evidence, which kind of comes from lean startup a little bit, but a variety of other places. And we did it, and we set up a distributor in automotive, theater lighting, building lighting, outside building lighting, street lighting, residential, etc. And we kind of all put bets on which one we thought would win. The one that won was automotive. Now this was like 6 years ago, I guess, 5, 6 years ago. And everyone has, all the lights in automotive is now LED. But it wasn't 5 years ago. And so they made the LEDs, but the housings, etc., were made by people in the automotive industry. And so they use that. So don't make too many assumptions, kind of open the idea, and then use some evidence to help choose. The second one is this framework that probably people are increasingly aware of now, called jobs to be done. Understand what the job that technology can do. And that's a real fundamental difference and different approach than saying, what does that technology do? What functions can it do for people? And how can it help them? And so we do this job mapping. And by the way, and I'll explain it a bit more later, but when you're looking at jobs, the only person you look at is the person who's actually using the technology. So at the first version, it's who uses that technology. Later on, we'll talk about all the other stakeholders in the system that you have to be aware of who might get in the way of that user using it. But jobs to be done is a focus saying, what can you do for a user that no other technology can do? And of course, one of the differences in this approach is that you're really trying to focus on first customers and early adopters. You're not trying to focus on big market segments. So if you go back to the crossing the chasm stuff and all of those other Geoffrey Moore stuff, you're looking for those early adopters. You're not looking for the followers, even though that's where you'll make money. Because without a first customer, you won't get a second customer. And I know that kind of sounds obvious, but the importance of having quick first customers who actually validate your technology works, who help you understand what you're doing, are really, really important in de-risking this early stage. Of course, this is part of the problem, is that we tend to say, well, my first customer must be this big customer. One of the technologies I was involved in was a new technology that would allow, while you're writing in your pad, would be digitally capturing your pen and transferring it to the computer at the same time. So you end up with a printed sheet and a computer record. In addition, it had a little LED light at the bottom, so if you actually made a mistake, like you put a phone number in wrong or a postcode wrong, it would just flash red. So it was doing parity checking. And we had the idea that it would be used in hospitals. Doctors love pieces of paper. They put them at the end of a patient's bed and they fill them all out. And so we went to several hospitals and they loved it. And they said, well, we could do a trial, we could have this going, we could do a test, we could do our first installation in 2 years' time. Well, of course, we were a startup, we didn't have any money. In 2 years' time, the one thing we knew would be that we would be dead. So we said, well, thank you very much, we'll come back to you in 2 years when you're ready for us. And we talked to a truck driver, not the driver, but the person that owned a fleet of 8 trucks. And again, in Toronto, all of his trucks were going backwards and forwards across the border. And if you see the trucks when they go across the border, when they have shipments from multiple companies, they have so many pieces of paper, it's untrue. And they always get lost and they always get stopped and they can do pre-clearance. Anyway, it's a big mess. And he said, I'll buy them, I want to install them next week. So we said, well, how about 2 weeks? And we started with that. Understanding the first customer, the person that has that pain point early on, the one that's going to drive adoption, is really important. First customers are critical because without the first customers, you don't know the technology works. And even if you're applying it in a different sector or a different use, that first customer is critical. And it's a component of de-risking the whole process. So the next tool that we use in this process, and we have it's almost a formulaic way of going through it, is around value proposition. Now again, Alex Osterwalder has a great value proposition canvas, which actually has some of the components on it. But he defines it slightly different from what we do. We define value proposition in one way, and one way only. It's the motivation to adopt. You create a value proposition that makes a compelling reason for your first user to adopt the technology. And that means that you have a whole load of benefits, and you have to make the benefits bigger. And you have a whole load of costs, and you have to make the costs smaller. And only when the benefits are much, much bigger than the cost will that person adopt that technology. It's also important to remember that benefits are not just financial benefits or performance benefits. Sometimes they're emotional benefits. Sometimes they're associated with risk. Similarly, costs. If you're looking at the cost of installing a new technology, it includes costs like the cost of installation, the cost of training, cost of compatibility, the risk that the technology company won't even be there in the future. So we create around this model a model of a value proposition that puts all the pluses on one side and all the minuses on the other side, and says, what can you do to change that? And I'm going to explain in a second how we use that a little bit more detail to talk about different versions of the technology and different business models. A value proposition is right at the heart of the early stage of finding first customers. Because we kind of have this joke that inside large organizations, or even individual behaviors, everyone has this thing called innovation inertia. Innovation inertia is the fact that you won't change things. We actually have this paraphrase, and I'm going to misquote it because I don't know off by heart, but we paraphrase Newton's 3 laws of motion, and which says that without a significant force, a body will continue in a path without changing. And so the answer is our value proposition has to be the force to do that. It also says that bigger organizations or bigger masses are harder to change the direction of than smaller ones, which explains why universities don't usually be first adopters and big companies don't. It's easier to get the smaller trucking company to be the first adopter than the hospital. And finally, he says that for every reaction, there's a reaction equal but opposite in direction. And if you've tried to introduce new technologies in large companies, you will absolutely know what that means. The value proposition is a way to list all the things that are going to create that force, that motivation to adopt. And by understanding that and looking at individual aspects of it, you can actually increase the motivation to adopt by increasing the value proposition. The next thing we look at is stakeholders. Now, there's lots of models of it. There was a technique I used when I was selling in corporate. I think it's called Millett-Hyman. It's where you do stakeholder analysis of all the people in the large organization that can influence the purchase. And you have coaches and economic buyers and users and standards people. In our analysis, we only look at one thing. Who can say no? Who can stop you from using that? You're the user. That means you have a motivation. Who can stop you? Is it the operations person? Is it the finance person? Is it standards? We make a list of all of those people, and then we take the top 3 or 4 and find out why will they say no, and therefore what can you do to stop them from saying no. And we use that value proposition equation again, but very much more focused down at the detailed level. If it's someone that's very interested in making sure that it's safe, the value proposition has to really be that they have no concerns about safety. And so you work on that. So you build this model of all of these different barriers, and it becomes quite complex. But it helps you actually de-risk the commercialization technology process, because down the road you're not going to have those people stopping you from being successful. Or if you find a roadblock that you can't get around, you just say, hey, we can't get around it. There's no point in trying to sell this technology to that person or that company, because that person's going to say no. Or you can even ask them, what would it take to make you say yes? And we have lots of examples of that, and I'll tell you those in a second. Part of the challenge for us when we do this stakeholder assessment is that when we're talking to our engineering students, when we're talking to our graduates who are working on research, they actually don't understand the complex decision process of when you're selling to B2B. They understand B2C quite well, but even that's more complex than they recognize. But they just think if you have a better piece of technology, then the customer's going to buy it. And you will be surprised if you sit through tech entrepreneur pitches, how many times they underestimate the number of people that can say no. So really, that's really a part of saying no and why they say no. And by the way, the reasons people say no is not just irrational. Most of them are very rational reasons. You just have to put, we kind of use a equivalent of a 6 thinking hats exercise. You have to put the people around the table and say, if you were in charge of safety in this plant, what would you want to know? One of my first startups, I'll tell another story about it in a second, but one of my first startups is a solvent recycling company. Worked in the printing industry. And we made, actually our first big, we made solvent distillation equipment. You put in a printing plant, it would take all the dirty solvent and it would clean it up, give you clean solvent back, and the ink, you could then recycle the ink as well. What we found is there were so many people in the plant that could say no, even though the economics was great, and even though the environmental benefit was great because you didn't haul away as much waste chemical. But there was the union, plant health and safety guy was worried it was going to explode, et cetera, et cetera. There were so many people who say no, and we had to kind of keep repackaging it so that we could automate it, we could watch it from a distance and control it, that we could shut down. It had some manual knobs on that cost us like $20 to put on the machine, and we replaced it with a $120 microprocessor that was completely overkill, but the customers liked it because they said, oh, it's an automated system, we don't have to go adjust it ourselves. So we just kept redesigning the product. By the way, the funny thing about that company, I'm still a shareholder in the company, but it never had an exit because I didn't actually understand that when you started companies you had to plan for an exit. I just thought if they made a good product and made money, it would be okay. So the order book this year has gone up by $1 million. We have $1 million backlog in the company. And I'm going, where did this come from? I'm talking to the guy we were equal partners, and now he's CEO. And he said, well, there's this new industry come up called marijuana. And in it, you have to put solvent into marijuana and extract the liquid. And all of these places are producing it, and now we're selling all these machines to all of these marijuana producing. So who knew? Anyway, that wasn't in our business plan. So limited understanding of the role. It's also difficult to get the engineers in the room to think about why people might reject things that's not based on technology. So I kind of indicated how we address that with the 6 thinking hats approach. But we just asked them to play the role. You're the safety officer in this new plant. Why would you object? And what could you do about it? Going back to my solvent technology company. So we were a Canadian company. We were trying to sell into the US. And there were all sorts of printing plants. And none of them would buy our technology. And we didn't know why, because they loved it. They tried it. They loved it. It was great performance. And we suddenly realized it's because they didn't know who we were or where we were from. And so we set up an agreement with a national distributor who was in the industry of selling solvents. And basically, everything went really well after that, because there was someone local that they could call. Now, all that person did was call us. And so they weren't adding that much value, but we overcame the barrier to adoption of no local representation by having a distribution partner. And there's many ways that you can do that. So the final thing we do is we say, okay, so now we have this. This is kind of the final stage of the class, last 2 weeks of the class. There's two things that we could do to change the technology to overcome these barriers, because we've already created a compelling value proposition. What could we do to remove the barriers? And what we change is the business model. So how can we change the business model? I just gave you an example. We set up a channel partner. The business model can also change the format of the technology. Sometimes you want to make the technology less accurate and lower cost. Sometimes you want to make it bigger, or sometimes you want to make it smaller. So changing the business model means changing the value proposition, because you change the features of the technology. Let me give you, I'm running out of time. So I have several examples, but one of them was measuring purity in milk. And one of my colleagues, Lassonde, they developed a lab on a chip that would measure impurities in milk. And it was like 99.99% accurate, and it could be better. And he wanted to build it into 10 big machines and put them in all the big dairies and deal with the issue of milk purity, because it's a big issue. And we started doing research about where was the biggest problem with contaminated milk. And it might surprise you, it might not surprise you. The biggest problem is in India, and the biggest problem is at the level of the farm, not the level of the dairy. And part of the reason for that is if you take milk that's contaminated at a farm and bring it back to the dairy and mix it with all the other milk, then you contaminate all the milk. So we said, could we make, instead of this big unit that costs $18,000, could we make a $200 handheld unit that they could use on the farm? And he goes, oh, well, yeah, but it would only be like 96% accurate. And we go, okay. We tend to think higher performance, more accuracy, etc. And he wanted something that was easy to replace the cells, long life, battery controlled, green light, red light, and not quite as accurate. So it's really a question of trying to understand it. So you change the technology form, you change the business model, you change the value proposition in response to barriers to adoption. And one of the most important things about that, and it kind of goes back to this question of licensing versus entrepreneurship, is that sometimes the best way to get over that barrier to adoption is by licensing to another company. Even though everything I do from the morning I get up to the time I go to bed is to try and create new technology ventures. Sometimes you just have to recognize that the best way to commercialize the technology is licensing, because it overcomes barriers to adoption, because they know how to do it, they can integrate it into something else, they already have the relationship with customers. So sometimes it's creating a new business because you want to disrupt the market, you want to change what's going on, and you want to add value. So our approach uses a whole bunch of different models that you will see. I think there's a couple in there that are unique, like the value proposition one, maybe in the barriers to adoption. But we work with colleagues. All of these, we've actually worked with the people that came up with the process. Like, we work with Bergeron, StageGate, and Osterwalder on business model canvas, Ambassador on creative problem solving. And we create this end-to-end process where each stage is what people go through. These are the canvases that we use in workshops. In the lessons, we just basically focus on one each week. And you can do them with post-it notes, you can do them online, you can do them shared across a community. The more diverse the community, the better the outcome. You probably guessed that already. So we lead with what jobs the people can do and who needs those jobs done. We look at how to create a compelling value proposition that creates a motivation to adopt. And then how do we overcome the barriers to adoption to make sure that we're actually going to get our technology out in the market. Each of these is incremental. Each of these means you can stop, pivot, or continue. And the final comment really is about entrepreneurship. Entrepreneurship may be a passion, it may be what some people want to do, but it's a choice of a business model that you should make based not just on individual motivation, not just on making lots of money, but based on de-risking technology commercialization by overcoming barriers to adoption. Thank you. My last slide vanished.
Good. So first of all, thank you very, very much, Andrew, for being here. He's going to also spend the bulk of the day tomorrow with us, so we'll do a little deeper dive. One of the things I'm really interested in is getting deeper into his canvases and the thought process and the way that we wrap teams around ideas in order to accelerate and improve the exploration of where to begin in terms of the multiple applications when we're early stage in the technology, et cetera. So we're going to definitely spend a little bit more time on that tomorrow. Really appreciate it. Appreciate all of you being here, and we're happy to stay around if you have additional questions. So thank you very much.